Adjacency matrix are used as a data structure for the representation of graphs. It is nothing but a square matrix used to describe a finite graph. The values of the matrix convey whether the pair of the vertices are adjacent or not. In graph theory, a pair of vertices are considered adjacent if they are connected. So in adjacency matrix, if the pair of nodes or pair of vertices are not connected, we represent them as 0, and if they are connected, then we represent them as 1. So this is how simple is the adjacency matrix. Now let's try to look at an example. We are given a number of vertices and pair of edges. So let's try to visualize this as a graph. Okay, so we have four vertices, 0, 1, 2, 3, and we have edges between 0 and 1, 0 and 2, and 2 and 3. So mind you, this is an undirected graph. There will be very slight difference between how we construct an adjacency matrix for an undirected graph and for a directed graph. So let's first look at an undirected graph. So this is how our graph looks. Now what we have done is we have created for all the four vertices we have created a blank matrix with all the four vertices on both the sides. So these rows will represent is the starting vertex, and this will represent the ending vertex. So let's try to form this adjacency matrix for these edges and these number of vertices. We see that there is no edge from 0 to 0, so the value will be 0. There is an edge from 0 to 1 here, so what we'll do, we'll add 1 here. Similarly, if you see there is an edge from 0 to 2, okay, so we will add 1 again here. Now there is no edge between 0 to 3, so we will add 0. Since this is an undirected graph, we will see there is a connection between 1 and 0 as well, so we will mark it as 1. For 1 and 1 there is no connection with 1 and 1, so it will be 0. For 1 and 2 we do not see any connection, so again we will mark it as 0. And similarly for 1 and 3 we will mark it as 0. Now from 2 and 0 we see there is a connection between 2 and 0, so we will mark it as 1. From 2 to 1 there is no connection, so we will mark it as 0. 2 to 0 2 to 2 is same. From 2 to 3 you see an edge, right? So we mark it as 1 here. Again, starting from the third vertex, there is no path between 3 to 0, so it is marked 0. There is no path from 3 to 1, so again 0. There is a path from 3 to 2, so we will mark it as 1. And again from 3 to 3 there is no path, we will put 0. So let's try to code this now. We'll jump to the code editor now. So I'm using a code pen. I'll share the link of this code pen in the description of the video as well, for you to clearly see all the like whatever solution I have made. So let's first define the number of vertices, right? So vertices are also called nodes, so you can say number of nodes as well. Here our use case was 4, and we have edges as well. So edges are 0 to 1, and then 0 to 2, and 2 to 3. So 2, 3. These are the things which are given to us. Now we have to write a function called convert to what we can say adjacency matrix. Okay, and we are given number of vertices and we are given the edges as well. Okay, let's try to make it a normal function. So this is how we define a function. So now first let's define the empty adjacency matrix first. So adjmat, this is a variable name. What we'll do is we'll create a new array of size of a number of vertices. So this is a 1D array. Now let's create a 2D matrix. So how will we create that? We'll go through each of the rows of the adjacency matrix and create all the columns. So for let row equals to 0, row less than, you can say, adjacency matrix dot length, which is same as number of vertices, and then row plus plus. And now we will start creating columns. So admat of row equals to new array, new array again with the number of vertices. So the columns and the rows and the columns should be equal. So this is creating the rows, and then for each row we are creating all the columns. And now we have we can initialize it with zeros as well. So all the values of the matrix will be pre-filled with 0 now, and this is what we will return. So let's write a return statement. Obviously we are going to form this adjacency matrix here. Let's try to print it out. Matrix equals to this, and we will, so basically we will do first this and then edges. So this is how we are calling it, and then console log we will just print this matrix. Now what we will do is we will uncomment it, and we'll see the value of current matrix. So you see we have created a 4x4 matrix, okay, and all the values are 0. Now what we'll do, we will write the code, actual code, to convert it to adjacency matrix. We'll clear this one now. Now let's go back to our problem statement. So what we'll do is we will go through each of the edges one by one. So we'll go through each of these edges one by one and try to form the matrix. So what we'll do is we can write a for of loop where we can do edge of all these edges. So this edge will contain each of the pair. Okay, so this is the advantage of for of loop present in our JavaScript language. The start vertex is edge of 0, and the end vertex, for better clarity let's write it as vertex. Okay, and vertex equals to edge of 1. Okay, so we are so in first iteration we will go to 0 1. This edge value will contain 0 and 1. So start vertex will edge of 0 will be 0, and end vertex edge of 1 will be 1. So let's write it out. So we have 0 comma 1 in first iteration, and this will be 0 and this will be 1. So what we have to do is very simple. We have to check for each of the pairs. So if we are at 0 comma 1, so we will check from 0 to 1 and 1 to 0, both we have to put 1. Okay, so what we will do is adjacency start vertex end vertex. From starting to end we have to put 1, and again from end vertex to the start vertex as well we will put 1. So we are doing this because this is an undirected graph. So 0 1 will also be 1, and 1 0 will also be 1. And this is how simple this adjacency matrix code is. We are done now actually. So now let's try to see whether we are able to successfully create the matrix or not. So I'm uncommenting it out, and the value should be here in no time. This is exactly the same as this matrix which we created. Okay, so this is how simple code for creating the adjacency matrix is. Now we have already done reading the undirected graph. Now let's go to a directed graph. The edges are same, the number of vertices are same. It's just that now we are considering it as a directed graph. So from 0 to 1 we will have a path. Now since this is a directed graph, we will consider only 0 to 1. 1 to 0 will not be considered now. Similarly 0 to 2 is a path, no, not 2 to 0, and 2 to 3 is a path, not 3 to 2. Now let's see what are the changes here. So the approach will be same. What we will do is, from 0 to 0 there is no path, from 0 to 1 there is a path, so we'll put 1, from 0 to 2 there is a path, so we'll put 1, from 0 to 3 there is no path, we'll put 0. In undirected graph we consider 1 to 0 as a path as well, but here we will not, there is no path, so we will put 0 here. And again, from 1 to 1 there is no path, from 1 to 2 there is no path, 1 to 3 there is no path, from 2 to 0 again there is no path, only path was there from 0 to 2, so we will again put 0, and again 0 0, and now 2 to 3 there is a path, so we will put 1, and then 0 0 0 0, because there are no paths. So this is how adjacency matrix for a directed graph will look like. So the code changes will also be very small. From start to end we had put 1, and end to start as well we had put 1. Okay, now since this is a directed graph, we will we will only have start to end, will not have any path from end to start, right? So we'll just remove this line or comment it out for now, and we will see the matrix here. This looks exactly same as this matrix. So this is the only change we do for undirected to directed. Okay, so we have reached to the end of the video. We have covered everything, what is adjacency matrix, and how to create it for undirected as well as directed graph. And I wanted to cover this topic because in future questions, when we are going to solve the lead code questions, we will make use of this concept. So that's why I wanted to cover this concept beforehand. And in next video we will be learning about adjacency list as well. So these are the two things we will use a lot while solving questions on graph. Please try to understand this concept. This is very basic, very easy, but very important as well. So let's end the video here. Thank you so much for watching. If you like this, give a thumbs up on this video, and subscribe the channel for upcoming tutorials. Thank you so much.